Hi learners, welcome again to the video for engineering thermodynamics. Going to discuss about actual vapor cycle processes, and this is part 2, right? So successfully I have completed around 36 videos together for first and third unit. Thanks for your cooperation and learning, happy learning. And now again I am going to continue with actual vapor cycle processes. Okay, now in the last video I explained what is the difference between actual cycle and ideal cycle. Ideal means that is not possible to have it in practical situation. Okay, it is that is due to when you are doing the things or any works. Okay, in the practical experience you would have suffered so many things, and the performance which you have expected before the execution of that work would be totally different during the execution, and of course the final result also would be entirely different than what you have planned. Okay, so planning like that, planning would be different from execution, and the final outcome would be totally different to what you have tried, right? It would be either better or worse than the expectation. Like that, here also whatever the equation and the various processes and idealization and the assumptions which made the processes to drawn in the plots. Okay, only because of the assumptions you could be able to draw in the PV diagram, TS diagram, HS diagram. Otherwise those processes could not be drawn as a continuous curve. Already you know reversibility only will give you a very nearer point so that they can able to join together, or otherwise since heat and work are path functions, it is not at all possible for to draw it on the coordinate. Since we should draw on the coordinates for the analysis purpose, we are assuming that they are reversible, they are adiabatic, they are maintaining the constant pressure, there is no any losses, there is no pressure loss, there is no temperature loss, everything whatever we are assuming is matching or performing, all the devices performing at the 100% efficiency, right? But in the second unit also certainly we studied that 100% efficiency for any machine is could not be achieved due to the irreversibility. So actual processes, actual means what happens really. Okay, so the processes of actual cycle, they are totally different from those of what we had in ideal cycle. Okay, they are not matching with each other, and of course their performance is lower than the ideal cycle what we have assumed. Okay, so let me explain one by one. Now you know very well thermal efficiency equation for the Rankine cycle is nothing but net work done divided by heat supply. Okay, so here we are going to concentrate what happens to net work done and heat supplied. That is why where the thermal efficiency, where the thermal efficiency is decreasing. Okay, what happens to net work done and the heat supplied, this we are going to discuss in detail. Okay, so we should get the net work done more and heat supply as less as possible to increase the thermal efficiency. Okay, but actually what happens is net work done is reduced with the higher intake of heat rate. Okay, this what happens in actual cycle. please, my dear students, listen. Actually, if you want to improve the thermal efficiency, the net work done has to be increased with the minimum supply of heat input. Okay, but in actual cycles the reverse is happens in such a way that net work output is reduced with the higher intake of heat supply. Okay, so why it happens like this? Now let me explain. This is the boiler pressure from boiler to turbine line. Here the pressure what they are expecting is P1 dash. Okay, what I'll show you here, what is this P1 dash? Okay, here and the pressure of P1 1 dash, superheated steam. Okay, here from boiler actually they are planning for P1. Okay, but it is taking higher amount of pressure. It needs to be supplied with, it needs to be, listen here, P1 here, P1 dash. Okay, the boiler, due to the pressure loss occurring because of the pipelines present in the boiler. Okay, instead of occurring that is taking the heat supply at the pressure of P1 dash, now the pressure has been reduced to P1. Okay, reduced to P1, and then the superheated pressure, so superheated steam pressure now reduced to 1 double dash, and then now here from point 1 only the turbine inlet process is expansion is started. What is this 1 dash to 1 double dash and 1 double dash to 1? Okay, this much pressure reduction or losses is being taking place. Okay, so here this is due to the conversion, that is while maintaining the pressure, during the superheating process, the pressure has been reduced from 1 dash to 1 double dash, and next stage during the turbine inlet, actually the superheating the turbine inlet condition should be 1 double dash, but because of the transmission between the boiler and the turbine, again pressure loss takes place, and actually that in the inlet of the turbine the pressure is only P1. Okay, here only the turbine expansion starts. Okay, and then now that is both piping losses and heat loss both together made the pressure to comes down from 1 dash to 1. Are you getting? Here heat loss occurs, here pressure loss due to pipelines. 1 dash to 1 double dash meant for pressure loss, and 1 double dash to 1 shows you the heat loss. Okay, now next, in the turbine what happens is usually if you want to, if you have earned well, means somebody what they will do, they will spend the money like anything. They will get many costly items. They will be leading a very luxury life, and they will not save anything for the future. But someone that is some other human beings, what they will do, no, they will be saving for future. Okay, they will be saving for future, and they will be leading a very normal life. unlike that another person who is spending and not saving any money for his future, right? Here the turbine that is those who are cautious, those who are cautious, they will be doing the any things before during the that is at the punctual time, or otherwise even they will come and attend the things before the required time. That is, if you want to go to interview, means if they are asking you to that is be in that in that office at 10 o'clock, means you should be there, or those who are cautious would be there at 9:30 itself, okay? But somebody they will come at 10:30, okay? So those who are good, usually those who are good, what they will do, no, they will be doing everything in a very conscious way. Like here what happens, I told about the latecomers, no, latecomers, those who are not punctual, not perfect in anything, like that. Here also this turbine and pump is a imperfect fellows. This culprits, what they are doing is, actually the turbine has to give you, for example, if you think that 100 kilowatt of power for some mass flow rate of around or 50 kg per second of steam, okay, it is delivering only 80, only 80 kilowatt, okay? What happens to that 20 kilowatt of power, okay? What happens to turbine where that particular loss is happens, okay? Is nothing but, we are assuming that turbine does not do any adiabatic process. It is following reversibility like anything, okay? It is purely following the reversibility, okay? That does not happens. Wear and tear and other friction, okay, very important, friction, wear and tear, blades erosions, and make so many pressure losses and heat losses, and of course the process could not be either adiabatic or reversible, and thus many losses will accumulate in the turbine, so that the delivered work output is not matching. Of course it is lower than what we have calculated in the paperwork, okay? That you have to understand. They are imperfect, these components are imperfect in the view of ideal cycle, okay? Now, so here the actually the process should be 1 to 2 years, that is isentropic process, but instead the process would be 1 to 2, that is it is not following the reversibility and as well as adiabatic conditions. So what happens, it will give you the lesser power than what we are expecting. And if you come to condenser, again pipe lossing and pressure loss occurs, and thus what happens is, here instead of this maintaining the pressure at P2, of course that is it is during the condenser process, that is cooling process, also pressure losses happens, and then of course when it is entering into the pipe, the loss is between P2 and P3, okay? Of course it has to be P3, but here the pressure is increased, and then we are getting the pressure loss in the condenser, okay? And if you take the pump, okay, let me continue this one in the next video again, I hope. Here if you take the pumping process again, instead of going to 3 to 4 is now here, again the irreversibility process made the pumping process to 3 to 4. Okay, so here also the irreversibility made the process in a wrong way, and more and more amount of work done will be taken by the pump compared to what we have calculated in the ideal